Let's see some examples of the quantitative comparison questions. The first question says that we have two quantities A and B. The first quantity is the least prime number that is greater than 24. So we know that the least prime number that is greater than 24 is 29. Quantity B says the greatest prime number that is less than 28. The greatest prime number that is less than 28 is 23. So on comparing these values A and B, we can say that quantity A is greater. So now you see the options. We can say that option A in this case is correct. Moving on to the second question. It says that x is an integer greater than 1 and then we have two quantities A and B. Let's see examples for x. Let's say x is 2. The first quantity says that 3 raised to power x plus 1 and quantity B is 4 raised to power x. So in this case 3 cube is 27, 4 square is 16. So in this case we can say that option A will be correct. But without properly seeing all the options that we have for x, we cannot actually reach to an answer. So we will see other values that are possible for x as well. Let's say x is 3. In this case, this will be 3 raised to power 4 and this will be 4 raised to power 3. 3 raised to power 4 as we all know is 81 and 4 cube is 64. So in this case also we can say that the option will be A. Let's see another value for x. Let's say x is 6. In this case, this will be 3 raised to power 7 which is 2187 and this will be 4 raised to power 6. That is 4096. In this case, we can see that out of 2187 and 4096, B is greater, which contradicts the above two that we saw. So in this case, we can say that based on the information that is given, the relationship cannot be determined from the given information. So in this case, the answer will be D. Let's see this question. It says that in the figure given above, ABCD is a parallelogram. We know that in this figure, A, B, C, D is a parallelogram and we know the value of this angle which is 125 degrees. It says that AD is 4 and DC is 6. That means AD is 4 and DC is 6. The area of ABCD and quantity 24. So now what is the area of a parallelogram? The area of a parallelogram is base into height. Because we do not know the height, by using Pythagoras theorem, the height will be somewhat this. If we construct the height, this will be the height. We all know that from this right angle triangle, the length of hypotenuse being greatest, the height will be some value less than 6. So if we compute the area of the triangle of this parallelogram, it will be 4 into some value that is less than 6. Now if you see the quantity B, it says 24. 24 is 6 into 4. So we can say that the area of the triangle will always be less than 24. So in this case, we can say that quantity B will always be greater than quantity A. Let's see another question. Okay. This question says that A, B and C are three triangles. The length and width of triangle A are 10% greater and 10% less respectively than the length and width of rectangle C. So let's say the length and width of rectangle C be L and B. So the length and width of rectangle A is 10% greater, length is 10% greater, which will be 11 by 10. Width is 10% less, which will be 9 by 10. So we can say that this value will be 99 by 100 of this area of C. Now we say the question says that we have another rectangle B. The length and width of rectangle B are 20% greater and 20% less respectively than the length and width of rectangle C. So 20% greater will make it 6 by 5L. 20% less will make the breadth as 4 by 5B, which makes it 24 by 25. So what we have to compare? We have to compare the area of rectangle A and area of rectangle B. Area of rectangle A is 99 by 100 LB, area of triangle B is 24 by 25 LB. So if you have to compare two values, two fractions, we make the bases equal. To make the base of this value as 100, we will multiply both the numerator and the denominator by 4, which will give us 96 by 100 LB. So now we can easily compare these two values, from which we can find out that the area of rectangle A is greater than the area of rectangle B. So in this case, quantity A will be greater than quantity B. Let's see the next question. It says that let S consist of all positive integers less than 81 that are not equal to the square of an integer. So let's see what all numbers does S, this set, contain. It contains all positive integers less than 81 that are not equal to the square of an integer. So let's see the squares of the integers that are less than 81. Square of 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81. We do not have to include 81 because it says that the numbers are less than 81. That means the list will be from 1 to 81. So we can say that this set contains these numbers, set S contains these numbers 1 to 81 except these numbers. So you can count these numbers 3, 4, 5, 6, 7, 8. So we can say that out of this set 1 to 81 we have 80 numbers. Out of this 8 we will not have these 8 numbers. That means this set S contains 72 numbers. Our quantity A says the number of integers in set S. So we know that the number of integers in this set S are 72. Quantity B says 72. So we can say that quantity A is equal to quantity B. Pertaining to this, we have option C, which says that the two quantities are equal.